Good evening. Okay, so last week we have not met at all. Okay, so I hope you had exams. How are your exams? Okay, so last to last week we have met. So that time we had started with D and F block elements, right? So before that, we have completed haloalkanes and haloarenes. So we have just started with D and F block elements. So we have covered the key terms, right? We have covered almost the D block elements. So just we'll revise once, and then we shall proceed further for the some of the important compounds. Okay. So we have seen D block elements. What are D block elements? So these are called as transition elements. So where they are placed? They are placed in between that of S block and P block elements, right? So these transition elements are mostly what? They are metals. So metals, you know what are the characteristic properties? So they have high tensile strength, right? They have the property of malleability and ductility. Means what? They can be converted into thin sheets and thin wires, okay, in the form of thin sheets, okay, and in the form of thin wires. Then they are good conductors of heat and electricity, okay. So they are having shiny surface, right? So they are different. So whatever the metals, okay, so good properties, whatever the characteristics are possessed by a metal. So these all metals, so these all characteristics are possessed by the transition metals also. Okay. So transition metals, okay, so they have what? They have high melting point and boiling point. Why? Due to the stronger interatomic bonding. What do you mean by interatomic bonding? Between the two atoms, okay, so the bond which is present to hold the two atoms together are called as the interatomic bonding. So the melting it, so it has a high melting and boiling point. Then when you're talking about atomic and ionic radii, so you know across the period, what will happen to atomic and ionic radii? It goes on decreasing. Why it goes on decreasing? Because due to effective nuclear charge. Okay, so as you go across the period, what will happen? The nucleus will tend to pull the electron, outermost electron, more strongly. As a result, it will tend to pull towards itself and the size will go on decreasing. So as you go across the period, okay, as you go across the period, what will happen? The atomic and ionic radii goes on decreasing. Okay. So when you're talking about transition elements, okay, when you're talking about the atomic and ionic radii, so the atomic and ionic radii of transition elements are smaller than that of S block elements, but they are larger than that of P block elements. Okay. Then so among the elements, okay, DD transition series. So DD transition means what? 3D transition meaning. So you have 3D, 4D, 5D. Okay, so 3D transition series, that is scandium, does not show variable oxidation state. Oxidation state means what? The valence electrons. Okay, valence electrons means the remaining electrons which are available in the valence shell. Okay, so these valence electrons, they will be responsible for the variable oxidation state. So it shows the variable oxidation state. So scandium, it does not show variable oxidation state. Variable means what? More number of oxidation state. And while manganese, it shows maximum number of oxidation states. So these are some of the important points for D block elements. Then we have seen about transition elements. So transition elements, they form colored complexes. Why? What is the reason? Because the color of this complex is due to the absorption, because it absorbs the light. Okay, when it undergoes a DD transition, means what? If the electron is in the ground state, okay, what it will do? It will try to excite. Okay, it will try to excite to a higher energy state. How it will excite to higher energy state? It takes energy. Okay, it takes energy, and the electron from the ground state, it jumps to the higher energy state. And then what happens? It will be unstable. So it will be unstable. So when it comes down to the ground state, so it will emit radiation. So this will be responsible for the color of the transition element. So the color of the complexes is due to the absorption of light. Okay, due to DD transition. DD transition means what? It is undergoing transition from 0 level to 1 level, or from 1 to next level. Okay, from a lower to a higher energy. Okay, so it is due to partially filled d orbital. Partially filled means what? It is not completely filled. So you know, in d orbitals, there can be how much electrons can be accommodated? Maximum number of electrons can be accommodated is what? 10. So 1, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 number of electrons can be accommodated in d orbital. Partially filled means what? Either it is half filled or it is not completely filled. Okay, so it is called as partially filled d orbitals. So then we are going to study with some of the oxometallic compound, okay, that is potassium chromate, potassium dichromate, okay, potassium permanganate. So these are some of the compounds which we are going to study. So about lanthanides, we'll be dealing after this D block elements. So we have completed this. Then we have seen the general properties also. You know that they form stable complex. They are hard and have high density because they are metals. Okay. So they have high melting point and boiling point. Why? Because they are metals. They show variable oxidation state and they form colored ions and compounds. Okay. So these are some of the what you can say properties of the transition elements. Okay, so they are often paramagnetic. Why do you mean by paramagnetic? Paramagnetic means they have unpaired electrons. Okay, paramagnetic means they have unpaired electrons. Suppose this is a unpaired electron, so there is only one electron present, right? So this is responsible for the paramagnetic behavior. Okay, what do you mean by diamagnetic? Diamagnetic means what? The electrons will be paired. Okay, so the electrons will be paired, for example, like this. So if the electrons are paired, then it gives rise to something called as diamagnetic. Okay, so this also we have discussed, so we'll see again in further. Okay, so we are just brushing up the things because there is a gap of 1 week. Okay, so it will just recall all your things. So next is metallic character. So all the D block elements are metals as the number of electrons in the outermost shells are 1 or 2. So the outermost electron, the number of electrons will be present is only 1 or 2. So all the D block elements consist of metals. Okay. Then, so these are, so metals, you know, what are the characteristics of metals? So we'll not go again in detail. So they are good conductors of heat and electricity. Okay, due to free electron, they can act as a good conductor of heat and electricity. So, the presence of partially filled. So as we have discussed, so because of the partially filled d orbitals, it gives rise to covalent bonding and metallic bonding. Okay. So, so this is a more favorable due to possession of 1 or 2 electrons in the outermost energy shell. So these are some of the characteristics of metallic properties. Okay. Then reducing property, we have seen density. You know, density is what? Density is equals to mass upon volume. Okay. So as you know, as you go down the group, what will happen? The size will go and increases. As size increases, density also increases. So this is okay. Then melting point, boiling point also we have discussed. So stronger metallic bond and presence of covalent bond formed by unpaired d electron. Okay. Why the melting and boiling point of d block element is stronger than that of s block element? Why it is more? Okay. Melting and boiling point because the stronger metallic bond is present and presence of covalent bond which is formed by unpaired d electrons. Okay. So these are some of the what you can say characteristics or properties of D block elements. Next, we had seen with the formation of complex compounds. Okay, so transition elements, as we have discussed, so they form large number of complex compound. Why? What is the reason? Due to the small size. Okay, metals, as they are small size, they are high ionic charges and availability of d orbitals for bond formation. So so if the question is asked, what is the reason why transition elements form large number of complex compound? Why? What is the reason for formation of large number of complex compounds? So what is the reason? What are the points? So first point is smaller size of the metal ions, high ionic charge, and availability of d orbitals of bond formation. So these are 3 points for what you can say formation of large number of complex compounds. Okay, so it should have small size. The transition metal should have small size. They should have high ionic charge. Okay, then there should be availability of d orbital. Availability means what? There should be free d orbital so that it can form this. Okay, it can form complex formation. It can undergo bond formation. So these are some of the points which you need to remember. So next is catalytic properties. What do you mean by catalytic properties? So most of the transition elements, as we have discussed, they are acting as a catalyst. So what is the role of a catalyst? So catalyst, it will enhance the rate of the reaction. It enhances the rate of the reaction. That means it increases the activation energy. So so suppose a reaction, it requires 1 hour. Okay, so if you make use of any catalyst, so your transition elements or transition metals, they can be acted as a catalyst. So if transition metals, if you're making use of a transition metal and you have so if it is acting as a catalyst and if you have added that into your reaction, then instead of 1 hour, your reaction will take place in 15 minutes. Okay, so catalytic property means what? It will enhance the rate of the reaction. The rate of the reaction will be much faster. So what is the reason here? So most of the transition metals are used as catalyst. What is the reason why they are used as a catalyst? Because of presence of incomplete or empty d orbitals. Okay, so they are incomplete. Incomplete means what? They are not completely filled, or due to the empty d orbitals. Then due to large surface area. Okay, then it has a property of showing variable oxidation state and availability of to form complexes. So these are some of the points. So these are some of the elements you can see here, which can be which are used as catalyst. So you can just make this a point. Okay, so what are the catalyst properties? Why the transition elements or metals, they are acting as a catalyst? Because of presence of incomplete or empty d orbitals. Next point is large surface area. Next point is variable oxidation state. Variable oxidation state means what? It will show different oxidation state. For example, Fe. Okay, Fe will show +2 as well as +3. So this means what? It can exhibit in two oxidation state. Okay, so one is it can exhibit in +2 and another is +3. Okay, like that. So nickel can exhibit in +2, nickel in +3, like this. Okay, so like this you can say variable oxidation state. So these are some of the key points. So next is large surface area. Okay, then availability to form complexes. So please note down this metals: Fe, then nickel, then V2O3. Okay, vanadium oxide, then platinum, molybdenum, and cobalt. Okay, so these are some of the metals, transition metals, which are acting as a catalyst. Then next is formation of interstitial compounds. So we have already discussed this. What do you mean by interstitial compounds? Okay, so transition metals, they have voids. Voids means what? For example, if I take a octahedral void, okay, so here you can say this is a void. So here in between this, okay, so this is a void. I'll just represent with one color. So I'll just represent it with the yellow color. So you can see this is a void. Okay, so this void, so transition metals, they have voids or interstitial. Interstitial means what? Small space. Okay, so some small elements like carbon, hydrogen, okay, nitrogen, boron. So these are the elements which are having small size. So these can fit into this spaces, okay, into this interstitial spaces. So so this results into compound called as interstitial compound. So transition elements, okay, so they will make up such compounds. So it helps in formation of interstitial compounds. So transition metals, they will be having voids. Voids means empty spaces or small interstitial spaces, okay, in between two. Okay, interstitial, so small spaces, so wherein your small atoms like carbon, hydrogen, nitrogen, okay, boron can fit, and thus it forms in the leading of interstitial compound. So these are called as non-psychometric. These are called as non-psychometric, as a composition is not fixed. You cannot say that in that particular void only one carbon has fit, or one hydrogen has fit. It can be 1.5, 1.8. It will be non-psychometric. Psychometric means what? The ratio is fixed. That is, one carbon has only fit. Okay, one carbon has only fit, or two hydrogens are only fit into that space. But non-psychometric means what? It can be 1.8, okay, 1.4 to 1.53. So the number is not fixed here. So whenever it results into the formation of interstitial compounds, so these are called as non-psychometric. Non-psychometric, the number or the composition is not fixed. For example, steel. Okay, for example, steel. So when you are making up the steel compound, so your the ratio is not fixed. So you know, steel, they are harder, but they are less malleable and ductile. Okay, so they are less malleable and ductile. So these are some of the 3 points. So remember this. These are the main 3 important properties, you can say, of complex compounds. So first is what is the reason for a large number of complex compounds, that you have to remember. Next is it behaves like a catalytic properties. Next is formation of interstitial compounds. So these are certain points you need to remember. Very important. Okay, these 3 are very important concepts, you can say. Next is alloy formation. So you know what is alloy? So alloy, it is a homogeneous mixture. Homogeneous mixture means what? When 2 or more substances combine uniformly, okay, without any separation. So homogeneous mixture, so of 2 or more metals. So alloy is formed by a homogeneous mixture of 2 or more metals. So when 2 or more metals combine, they form alloy. So due to the comparable size of the transition metals means what? When the transition metals which are having same size, comparable size means almost they are, when the 2 or more metals, when whichever metals you are taking, suppose you have taken 2 metals, okay. So these 2 metals, okay, so they should have same size. Okay, so alloy, it is a homogeneous mixture which is made up of 2 or more metals. So due to the comparable size of the transition metals means what? So when 2 or 3 metals, they will have same size. Okay, the size, that is, they are having same comparable size of the transition metals. So here what happened? One of the metal can displace the other metal in the crystal lattice. So when one metal which is having say comparable size with the other metal, so what you can do, if you're forming a crystal, suppose it has been formed as Na plus Cl minus, okay, Na plus Cl minus lattice crystal is formed. So suppose Na plus, so what I can do, instead of Na, okay, so I can replace it with cesium, Cs, okay, like this. This is not a example of transition metals. I have just taken an example. Okay, so suppose there is a crystal lattice, that is Na plus Cl minus, Na plus Cl minus. So if I take a element which is similar to this, that is Na plus and Cs plus, okay. So that time what will happen? So Na can be replaced with Cs, that is, which is having a same comparable size. Okay, so the alloy is so formed, they will be hard. So the alloy which is formed, because the metals, they are having 2 metals, they will be having same size, which is of comparable size. Okay, so the alloys so formed are hard and they have high melting point. Okay, so they have high melting point. So alloy is a homogeneous mixture which is made up of 2 or more metals which is having same comparable size of in the transition metals. So remember this one point. So alloy formation is also very important property of transition metals. So next property is color property. Okay, so most of the transition elements, as we have discussed, so they are exhibiting the color property. Why? It is due to the dd transition of unpaired electrons in their T2G and Eg set of orbital. Okay, so it is due to what? It is due to dd transitions of unpaired electrons in their T2G and Eg sets of 3D orbitals. They require less amount of energy to undergo excitation of electrons. So the amount of energy which is required for getting excited, okay, so it will be less. So they absorb. So whenever the energy is to be absorbed, it should be absorbed from the visible region. Okay, it should be absorbed from what? It should be absorbed from visible region. So they require less amount of energy to undergo excitation of electrons. So color property is very important. So it is most common in the transition metals. Okay, so why it is? It is due to DD transition of unpaired electrons. Okay, so for the getting excitation, they require less amount of energy, and this energy is absorbed through visible region of light, which is exhibiting the color. So these are some of the properties. Okay, color property is very important property. Then next is magnetic property. So magnetic property is also very important property. So transition element, they exhibit magnetic property. Okay, so we have discussed two things. So one is paramagnetic behavior, another is diamagnetic behavior. So these are exhibited by transition elements in the presence of unpaired electrons. Means what? If the electrons, okay, so if the electrons are unpaired meaning what? It is not paired. Okay, then it will show what property? It will show paramagnetic property. So a paramagnetic property, it will be attracted to magnetic field. The free electrons which are present, they will be attracted to magnetic field. So this paramagnetic property, it is due to unpaired electrons in atoms or ions or molecules. So this will vary inversely with temperature. Okay, so this is about magnetic property. Next is diamagnetic substance. So diamagnetic substance, what happens here? It is slightly repelled. Repelled means what? It is not attracted. It is reflected, you can say. Okay. So it is slightly reflected or repelled by a magnetic field, and it is independent of temperature. So here all the, what you can say, all the electrons, they are paired. Okay. So the electrons in diamagnetic, okay. So there the electrons are paired. Now, as a evident, most of the transition metals, they are having unpaired electrons, okay, in their d orbitals. So, unpaired electrons, so they will be paramagnetic. So, what you can see, most of the transition elements, okay, most of the transition elements, what we can see is that the electrons are unpaired. Okay, so electrons are unpaired. So what we can do, so as a transition metal, they have unpaired electrons in their d orbitals. So most of the transition metals, they are paramagnetic in nature. So they will be paramagnetic in nature. Why? Because the electrons are unpaired. So these are some of the examples. Okay, so these are examples wherein the electrons of some of the transition elements are unpaired. Then this we'll see later. Okay. So these are some of the important key features of magnetic properties. Then we have seen about non-psychometry. Non-psychometry means what? The composition is not fixed. Okay. So non-psychometry means what? Non-psychometry means composition is not fixed. So here they are indefinite structure and proportion. Proportion means what? It is they are having they are not having fixed proportion, as we have discussed. Okay, they are not having fixed proportion. They will be not having fixed proportion. Okay, they are having indefinite structure. Indefinite means what? They will not have proper proportion. For example, see here they have given. Okay, iron 2 oxide, FeO, should be written as a bar over the formula FeNO, which is not exactly 1:1. So if FeO is present here, okay, so what is given here? FeO 84 oxygen. Okay, so the number here is, the composition is not uniform. The composition is not uniform. Okay, now non-psychometry. Okay, so it is caused by the defect in solid structure. What is the question? Diamagnetic substance means what? For example, if I take zinc, okay, for example, zinc, if I take, zinc is what? Zinc is +2. Okay, zinc will always exhibit in +2. So it will be argon 3d10. So here all the electrons are completely filled, right? So this is an example you can say for what is that? Diamagnetic substance. So diamagnetic substance you can take example as zinc Zn plus 2. Okay. So this is a one of the example you can give of diamagnetic substance. So we'll go for the next one. So alloy formation we have seen. So now we'll go with the important compounds of transition elements. Before that, there's something called as magnetic. Now we were discussing about magnetic property right here. Magnetic property. So here magnetic property, here you can see they have given something called as magnetic moment. Okay, so we can calculate this magnetic moment. Okay, here you can see magnetic moment. So the total magnetic moment of a substance is a resultant of magnetic moments of all individual elements. Now, what is this magnetic moment? Okay, so the paramagnetism. So most of the transition elements, as we have discussed, they are paramagnetic. Why? Because of the presence of one or more unpaired electrons. So hence they are attracted to what? They are attracted to magnetic field. Okay. So this paramagnetism behavior is measured in terms of magnetic moment. So this behavior of the electrons, okay, it is what? It is measured in terms of magnetic moment, which is given as mu. It is given as mu, and its unit is Bohr magneton. Okay. Please note this down. Very important. Magneton. So important questions are asked based on magneton. Okay. So more magneton. So that is magnetic moment. So magnetic moment, it is given as mu. So and its unit is Bohr magneton. So magnetic moment, it is related to number of unpaired electrons. So you have to calculate how the number of unpaired electrons are to be calculated. So where so it is given as mu is equals to. So you can just write what is magnetic moment. So the this what is okay. So the paramagnetism is measured in terms of magnetic behavior. Okay, magnetic moment, and its unit is Bohr magneton. What is the unit? It is Bohr magneton, and the magnetic moment, it is related to what? It is related to number of unpaired electrons. So how it is given? Mu is equals to, I'll write here, mu is equals to root of n into n plus 2. So this is the formula we have to use. So where n is what? N is number of unpaired electrons. So where what is n? N is the number of unpaired electrons. Now suppose I want to find out. Okay, I'll go behind. I'll take a free slide. Okay, so here I'll write it here properly. Magnetic moment given as mu, unit Bohr magneton. Bohr magneton. The magnetic moment is related to the number of unpaired electrons, as mu is equals to root of n into n plus 2. So this is the formula where n is number of unpaired electrons. Okay. So magnetic movement, what will happen to magnetic movement? So magnetic movement increases. So it increases with increase in number of unpaired electrons. Very important. Okay, so this in magnetic property, this is very important. Okay, so questions are asked based on magnetic moment. Now, suppose ion is given as scandium, scandium plus 3. Okay, when you write the configuration of scandium, so scandium, what is the this scandium? Just see, write the electronic configuration of scandium first. Scandium will be 21. Okay. Scandium will be 21. So this will exhibit as Sc, that is scandium plus 3. So when you write the electronic configuration, okay. So it will be, this electronic configuration will be for scandium. First I'll write for scandium, just here. Scandium. First I'll write for scandium. Scandium will be argon 3, 3d1 4s2. Okay, so scandium is in +3 state. So this will be what? Argon 3D 3, right? So scandium +3 means what? All these 3 electrons will go. So this will be 3d0. Okay, 3d0, 4s0. So it will be 3d0. So, number of electrons, unpaired electrons will be 0. So number of unpaired electrons will be 0. So if you calculate magnetic moment, so mu also will be 0. So it will be 0. So magnetic moment is 0. So this will leave now. So next we'll go for what? Next we'll find out for, we can find it for Mn. Okay, Mn, what is the, what you can say? Electronic configuration of Mn is 25. Okay, Mn is 25. So it will be argon 3d 5 4s2. Okay, so Mn is 25. So it is 3d5. So it will be 3d5 4s2. So Mn will exhibit as +2. So it will be +2 means argon 3d5 4s0. Okay, it will be 3d5 4s0. So number of unpaired electrons. So how we'll write the unpaired electrons? Just see how the electron filling will takes place. You know. Okay, you have studied this in first year. Unpaired electron filling of electrons will takes place first singly, right? So 5 electrons are there. So first the electrons will be filled singly and then the pairing will takes place, right? So this is the rule. So 5 electrons are filled. First the electrons are to be filled singly and then the what will happen? Then the pairing will takes place. Now we will use this formula. So pi is equals to mu is equals to root of n into n plus 2. Now how many unpaired electrons are there? 1, 2, 3, 4, 5. So 5 into 5 plus 2. So what it will be? Just calculate. So 5, 7. Okay. So 5, 7 is 5. Root of, just see what you will get. Root of 35. It will be 5.91. Okay. So this is the answer. Understood? Understood this one? Yes. Good. Okay. So like this. Understood? So this is very important. Magnetic moment is very important. So what you need to remember. So from scandium. Okay. So yes, you have to write the unit as BM. Bohr magneton. Okay, remember that capital BM. So Bohr magneton. So this is very important. Okay, so you have to write the unit as Bohr magneton. So you have to write this form. I hope this is clear. Okay, so I'll give you. You have to write. So I'll give you all the what you can say elements. Okay, with the charges. You can just find for everyone because this is very important from exam point of view. So for this, what is that? Objective points of view, they give, okay, they will give you different answers and you have to find the answer and you have to match it. Okay. So first you can find for scandium +3, which we have done. Second is titanium +3. Third one is titanium +2. Then fourth one is palladium plus 2. Fifth one is chromium plus 2. Then sixth one is Mn plus 2. So Mn is very important. Okay, Mn is very important. Then is Fe plus 2. Then eighth one is cobalt plus 2. Then ninth one is nickel plus 2. Then 10th is copper plus 2. Then 11th is Zn plus 2. So you have to find the, what you can say, find it for everyone. Okay. So find, you have to know the atomic number. Then uh, you have to find the, this. Okay. One more question, if this is the question. Okay, now I'll ask you one more question. You have noted down. Okay, I'll write the question here. So you have to tell me, calculate. So if a question is asked like this, okay, calculate, you have to tell me the answer. Okay, calculate the spin only magnetic moment of M plus 2 ion. Okay, whose atomic number is given as 27. So like this is the question. So now you have to find the magnetic moment. What they have given? They have given a metal. So they have told that the metal is in plus 2 state. What they have said, the metal is in plus 2 state and its atomic number is 27. Okay, and you have to find its magnetic moment. So can you tell me the answer? Try solving this. Try solving this. Which is the metal which is having 27, this 27 as the atomic number?
Cobalt.
Yes, cobalt. Good. So now solve it accordingly. Okay. Priyanka has answered it as 7.93 bm. No, not 7.93 bm. Okay, cobalt is the right answer. So cobalt will be argon. Okay, 3d7. Then, okay. So, cobalt, okay, solve this, others also solve this. Three D 7 4s2. Okay, now if cobalt is in plus 2 state, so this will be argon 3d7. So now we'll fill up the electrons. 3d7, 1, 2, 3, 4, 5. So how? 1, 2, 3, 4, 5. Then 6 and 7. So pairing will take place. So how much electrons are there? So the formula is n into n plus 2. Mu is equals to, okay. So mu is equals to, how many unpaired electrons are there? 1, 2, 3. So 3 into 3 plus 2. Okay, so it will be 3 into the 3 plus, this will be 5. So 5 threes are 15. Okay, 15. What is the square root of 15? Just see. So square root of 15. Square root of 15 is 3.87. Okay, so like this. Understood? Everybody got it? Yes. Good. Okay, so it is 3.87 bm. Okay, so like this you have to solve it. Understood? Okay, so like this, so this is the correct form of solving it. I hope this is clear. Okay, so we'll go for the next. So important compounds. So these this is important from theory point of view. Okay, so one of the potassium dichromate, that is potassium dichromate, manufacture of potassium dichromate from chromate ion, like that question is asked from this what, for exam point of view, theory point of view. Okay, then how the questions are asked in terms of need. Okay, so they may ask you the preparation. So what is required. Okay, so which is the, in preparation of potassium dichromate, so which is the ore which is used, what is the formula of the ore, like that the questions can be asked. Then FeO, that is ferrochrome or chromate. So you have to remember the what is that, the composition of this ore. Okay, ferrochrome or chromate. So like this, here the questions are from the need point of view, they are asked like this. So what is the ore, what is the composition here. Okay, so what is the preparation. So you have to take this ferrochrome. Okay, you have to take ferrochrome and react it with sodium carbonate. Okay, you react it with sodium carbonate in the presence of oxygen. Okay, that is excess of air. 7 H2O means 7 oxygen means what? Excess of air. Okay, either you have to take ferrochrome or chromate ore is taken. Okay, so it forms what? It forms sodium chromate. So this is sodium chromate, then ferric oxide and carbon dioxide. So here the first reaction, it gives you yellow color. Okay, because of the sodium chromate which is formed here, it gives you yellow color. So the solution turns here yellow. Now this yellow solution of sodium chromate, it will be filtered. Okay, so this solution of the sodium chromate is filtered and it is acidified. Acidified means what? You are adding acid here. Okay, which acid? Sulfuric acid can be added here. Sulfuric acid, you are acidifying the solution. You are acidifying the solution with the help of sulfuric acid. And to get what? You are getting sodium dichromate. You get what? Sodium dichromate. So your sodium chromate is formed. Your sodium dichromate is formed. This turns the solution orange color. What turns? It turns into orange color solution. Now this orange color solution is further what is done. This potassium dichromate which is obtained, it is treated with potassium chloride solution. Okay, and you get what? You get potassium dichromate because you have, what you have done, you are replacing your Na plus ions are replaced by Ka plus ions, and sodium dichromate is converted into potassium dichromate. Only there is a, you can see a displacement reaction is taking place, right? So Na plus ions are replaced by your K plus ions. So your sodium dichromate is more soluble than potassium dichromate. Okay, so the properties, so the second is chromates and dichromates are interconvertible in aqueous solution depending upon the pH of the solution. So these are some of the properties and preparation of potassium dichromate. So remember this 3 steps. So what all you need to remember? Remember which is the ore, what is the formula, ferrochrome or chromate. So ferrochrome is FeOCr2O3 or chromate is FeCr2O4. Okay, what is the preparation? So your dichromate or ferrochrome, sorry, chromate or ferrochrome is treated with sodium carbonate in excess of oxygen to give you sodium chromate solution, and ferric oxide plus carbon dioxide. This solution will be yellow color. Okay, the sodium chromate solution obtained will be yellow in color. Now this yellow color solution is acidified. Acidified means what? You are adding sulfuric acid to that. Okay, that is to the sodium chromate solution which is yellow color solution. You are doing acidification and you are converting it into sodium chromate. Okay, plus 2Na plus and water. So this turns, after acidification, the solution which is yellow is turned into orange. Okay, now this sodium chromate solution is treated with KCl. What is KCl? That is potassium chloride solution. Now this potassium chloride solution, okay, this potassium chloride solution is further treated with that is the sodium dichromate, and a displacement reaction is taking place. What is happening here? Your Na plus ions, okay, your Na plus ions are replaced by K plus ions. Okay, so this is the, thus this is the reaction. Okay. So dichromate is the primary standard. It is used as a volumetric analysis. Then most of the acidification reactions also you are making use of potassium dichromate. It is a good oxidizing agent. Okay, potassium dichromate. So these are some of the important points you can say for manufacture of dichromate. So remember these three steps are very important. Okay, and which is the ore which is used. I hope this is clear. Yes. So next is potassium permanganate, KMNO4. Okay, potassium permanganate is what? KMNO4. What is the ore which is used here? Pyrolusite. Okay, pyrolusite. That is MnO2. MnO2, what is the oxidation state? Can anyone tell me what is the oxidation state of Mn here? What is the oxidation state of Mn? Mn, yes. So here it is -2, -2, -2. This will be plus. This will be +4. So it is +4. Good. So it is +4. Okay. So just we'll see first the preparation. Okay. Structures we'll see in the next class. Okay. Just I'll both these preparations we'll see today, and structures I'll continue in the next class. Okay. So now ore, pyrolusite ore, that is MnO2. How is the preparation? MnO2. Okay, that is MnO2, that is your pyrolusite ore is treated with potassium hydroxide. What is potassium hydroxide? It is a strong base. Okay, in the excess of oxygen, so excess of oxygen is used and it is treated to K2MnO4. Okay, K2MnO4, that is potassium permanganate. Here, what is the oxidation state of Mn? So Mn from +4, it is converted to what? You can just tell me what is the oxidation state of Mn here? Not 8. Just see. Oxygen will be, see here. Oxygen will be what? Not +3. Not +7. See here. K2MnO4. Each oxygen is -2. So how many oxygens are there? 4. So 2 4s will be -8 here. Okay. This will be what? This will be +2 because each potassium will be +1. So this will be +2. Okay. Then this will be how much? Overall charge should be 0. So this should be +6. Right? 6, 7, 8, and this will be -8. So this will be 6. Understood? Yes, it is 6. So from Mn +4, it is going to +6. So there will be increase in oxidation. So it will undergo oxidation. So there will be increase in oxidation number. So it is undergoing oxidation. So it will turn the color into green. Then MnO4 ions, okay, it is acidified. So what we are doing first, MnO2 is fused with KOH, or you can use any strong base like NaOH, and you are going to use air in the excess of air. Then it gives you a dark green K2MnO4 solution. Okay, which is further it undergoes acidification. Okay, you are treating it with excess of acid, and it is giving you potassium permanganate. So this is potassium permanganate. So in brief, we will be discussing about these two in the next class. Okay. So for today, this much is enough, I guess. Huh? Any doubts you can ask me. For the structures, okay. So I'll do the structures. I'll do the structures in the next class only. So this one and the previous one. Okay, potassium dichromate and potassium permanganate, and we have one more. Okay, so these many we will do in the next class. Any other doubts? Okay. Shall we end the session here? Yes. Okay. Then, so we'll meet you in the next class. So I'll end the session here. Okay. So, okay, then I'll end the session.